Okay, this is going to be a short video to discuss how to find line of best fit using your graphing calculator. So this is when we're given a list of data points and we're looking for the trend line, the line that runs through the middle of our data. The calculator will actually compute the entire line for us. We just have to use the input function on our calculator to input the data. So the first thing we want to do is identify what the independent and dependent variable is. This is studied hours is going to be our independent variable, and our grade is going to be the dependent. Once we get that, you can actually go to your calculator. Let me get out of here. And before you get started, something I recommended for you to do during class was to go ahead and clear the memory in your calculator, and that way there's nothing existing in the calculator that was a weird window setting or whatever, data that was entered previously. So if we go to second mem, and if you notice here at the bottom I put the key history up, and hit 7 to reset, scroll over to all, hit enter, and say yes, and that'll just reset anything that's been in the calculator before. So once you get to this point, we can actually input this data directly into our calculator. We're going to put this in for our x values and this in for our y. So on the calculator, if you hit the stat button, and let me clear this out. So if you hit stat and then edit, we can actually input our x's for L1 and then our y's for L2. So I'm going to enter that in. These are all of my x values. You can just type them in and hit enter. 3, 2, 5, 1, 0, 4, 3. And then just scroll over to L2 and enter your y values. So this one was 84, 77. You want to make sure they match up perfectly. If you type in something wrong, like let's say I typed in 77 and on here it says 70, I can just scroll back up and type over top of it. 60, 90, 75. Okay. And it should match at the bottom because every x value has one y value to match with it. So once you've entered in your data, then we're going to head back to stat. We're going to go to calc and down to line reg, or you can hit 4 and you can see that it's ax plus b, which is very similar to mx plus b. And yours might look like this, or it might just say line reg ax plus b in parentheses. Either way, hit those. If yours just looks like kind of like what this top part looks like, just hit enter once. If it looks like mine, you can hit enter a few times to get it to calculate. And there's our equation right there. So y equals, usually to the nearest hundredth is good enough. 6.31 x. Remember, the more that you round, the less precise your answer is going to be, plus 62.05. So what I did right then was I just went ahead and wrote down what the equation of my line is. Now what's nice about this is if you had questions to answer, the best thing to use about line of best fit is to kind of make predictions for future data. So if you were trying to figure out, well, how many hours would I need to study in order to get a grade of a 95 according to this trend? So that would mean that if we wanted a grade of 95%, then that would be our y value. So we would enter 95 equals 6.31x. And you could actually go ahead and calculate what number of hours based on the trend line is. So when you go to solve that, I'm just going to do it quickly in my calculator. 95 minus 62.05 divided by 6.31. It says about 5.15. So you could actually do it to make predictions. Or if you could predict, well, if I study for 6 hours, what would my grade be like, and so on. So it's really great for making predictions. I'm going to show you now how to show it in the calculator, how to graph it. So your data that you've entered in StatEdit, this data is actually going to stay in there until you reset your calculator or we delete the data out. So if you're trying to graph the points, the first thing we can do is go to y equals. I can actually type in the line of best fit that I found. Oops, that's not right. 6.1. No, 6.31 x, and then plus 62.05. Okay, so there's my line of best fit. So if I went to graph that, see it's in kind of a weird spot. We'll look at that in just a second. So if I hit the graph button, but I'm actually going to go to second. Let me clear this out so you can see at the bottom. If you're trying to pull the ordered pairs up and actually plot those data points that we entered, if you go to second, y equals, to pull the stat plot, as long as your calculator's been reset, all of your stat plots will be turned off. So if you hit enter on the first one and turn it on, and notice there's all kinds of different types of options your calculator will graph, different settings and whatnot. Now your stat plot is on. The only other thing, if you're trying to look at it, because if I go to graph, it's still not showing anything, and that's because we can't really see our data points, because our data point range runs from, the x looks like it goes from 0 to 5, and our y's run from 6D to 92. So if we can go back on our calculator and actually change the window, so you go to window, and our x's were pretty 0 to 5, so I'm just going to type in 0. You could even do -1, really, so that way you can get a nice view. -1 to 6, and then our y's, we could go from, we can say 55 to 100, just so we get our range for our actual data that we have. Now after I change that in the window, I can then go ahead and graph, and you can see there's all of my data points there, and there's the line running through the middle of them. So that's how to find the line of best fit on the calculator. I'm going to do one more example. If you feel comfortable with this, then don't worry about it, but I'm going to do one more example using line of best fit. I'm just going to kind of go through it pretty quickly though. So this is our second problem here. It looks like this. The cost of raising a child that was born in 2003, the child's age, and how much it costs that child, or how much the annual cost is. So I'm going to enter in all this data into our StatEdit. So if I go to stat, clear all this out. Okay, so StatEdit, you'll notice your data is still in there from before. If you actually scroll up and highlight and hit clear and scroll down, it'll wipe out your whole list. Don't hit delete though, don't hit this button. So then clear. So it's 3, 6, 9, 12, and 15. Oops. And then the numbers are 10,700, 1170, 700, 12, 600, 15,000, and then 6, 7. Alright, so once you get your data, then you would go back to stat, calc, down to line break, or hit 4. And so there would be my equation. Now this looks pretty linear, so there's no decimals floating. It's probably pretty linear. So So it would be y equals 510x plus 8750, where x is going to be my child's age and y is going to be the cost annually. So if I go ahead and want to make predictions, I can do it from there. What would the cost be when the child's 5? So you would do y equals 510 times 5 plus 87. We know it's going to be between 3 and 6, closer to the 6. But if I go ahead and actually calculate it out, 510 times 3 or times 5 plus 8750. So when a kid's 5, according to this mathematical model, they're going to cost annually $11,300. Okay. All right. So after you get this, if you wanted to, I'm just going to do it kind of quickly, making sure your data is still in there, which it is. Okay. And we can go to y equals, and we can actually type in that equation that we found, 510x and then plus 8750. And if I hit graph, it's not probably going to show. Remember, our window is still setting the same setting from last time. So if we go back, it looks like my minimum's 3, my maximum's 15. So I'm going to go from 0 to 20 for my x. I'll clear out this list again because it's too messy looking. And the x scale, by the way, is just how many tick marks equal the scale of each tick mark. So each tick mark's worth 1. And then the annual cost, the minimum's 10,000. So we're going to go from 10,000 to we'll say 17,000, and that way it'll cover everything. Now once I go back to graph, there it is. There's my line. There are my points right through it. So that's all.